Hey guys, today we're going to talk about covalent compounds. So let's review what we know about covalent compounds. I know that covalent compounds share their electrons. So that's huge. I need to remember as I'm doing this that they share their electrons. So I'm not going to show a transfer like I did with ionic compounds. So let's look at our first example. The first thing I need to do is figure out how many valence electrons each has. So I look up on my periodic table and I know hydrogen has 1 and fluorine has 7. So hydrogen has 1 electron and fluorine has 7 valence electrons. That gives me a total of 8 valence electrons. So with covalent compounds, I'm going to do it a little different than I did with the others. I'm going to look at how many pairs are formed. So I'm going to take my number of total valence electrons and divide it by 2 so that I get 4 pairs. So as I go to redraw this compound, I'm going to draw my hydrogen and I'm going to draw my fluorine. I know that they have to be connected through a bond, so I'm going to draw that bond in. So instead of 4 pairs, I'm now going to have 3 pairs left because I've used 1. I know hydrogen is one of those oddball ones, and it only has that one s orbital, so it can only hold 2 valence electrons. So I know all the other pairs are going to go with fluorine. So I'm going to put the rest of the pairs there. So I've got 3 pairs to place. So I've placed 1, 2, 3. Now I need to check and make sure that my compound is good. So I know hydrogen, right here, that bond R represents 2 valence electrons, or represents 2 electrons. So that hydrogen has 2 electrons. While fluorine has 2 from the bond, 2 on top, 2 on the side, and 2 on the bottom. So that gives me my 8 valence electrons. So both hydrogen and fluorine are good. So now we're going to start with our second example. We're going to go to oxygen. I know that oxygen is written as O2. Oh, that's one of those diatomic molecules that we talked about. Remember those 7 of them? So I know that oxygen has 6 valence electrons, and there are 2 of them. So each compound, each molecule of oxygen has a total of 12 electrons that can be there. I'm going to divide that number by 2 because I know that it's a covalent compound and they're sharing those electrons, so I'm going to look at the pairs. So I've got 6 pairs. So I'm going to start similar to what I did before. Once again, I draw my electrons for each. That way I know that there's the 6. Then I'm going to draw my compound. So I have my 2 oxygens, and I draw that bond in first. So that gives me 5 pairs. Now I'm going to start placing those 5 pairs around my oxygen molecules. So I start at the far side and put 1 pair, 2 pair, 3 pair, 4 pair, 5 pair, and I'm out. I have no more. So now I check my oxygens to see if I'm good. Well, if I look at the first oxygen, I only see a total of 6 electrons around it, 2 pairs, and then the bond. The other oxygen is all good because it's got 3 pairs around it plus the bond. So I've got a problem. I need to fix this other oxygen. And this is where those things called double bonds and triple bonds come into play. So I'm going to actually take a pair of electrons and I'm going to slide them in between the 2 oxygens. So they're no longer down here. I can't just add an extra pair of electrons because there are no more left. So now if I look, I've got 2 pairs plus 2 bonds. That gives me my 8 valence electrons. I look at my other oxygen and I've got 8 valence electrons there too because of the 2 bonds and the 2 pair. So now let's try another one. Let's look at nitrogen. Well, nitrogen is also a diatomic molecule. That's why I have the 2 ends drawn. Nitrogen has 5 valence electrons each, so that gives me a total of 10 valence electrons. When I divide that by 2, I get 5 pairs. Are we guessing that we're going to be short? So, once again, I start by drawing my electrons around my nitrogen just to show that it has 5. Then I draw my 2 nitrogens. I draw a bond in between, so that takes me to 4 pairs left. Then I place mine around. So I've got 1 pair, 2 pair, 3 pair, 4 pair. Hopefully you realize this is a problem. Each nitrogen only has 6 valence electrons around it. Every molecule, remember, wants to have that magical 8. So I'm going to take 2 electrons and slide them in. So now my 1 nitrogen is good, the other one still is not. So I'm going to take another pair of electrons and slide those in. And here I have now formed my triple bond. So these are different ways I can do my molecules. The one other example I want to show you is if I have a molecule such as CH4. So I know that hydrogen has 1 valence electron. I know that carbon has 4. So that's 4 valence electrons from hydrogen. And that is 4 valence electrons from carbon. So it gives me a total of 8 electrons. When I divide that by 2 to get my pairs, I know there are 4 pairs. So carbon is one of those magical elements, and I know that it can make a whole bunch of different bonds. So it's going to be what I call my central atom. So I'm going to draw it in the middle, and I'm going to draw my hydrogens all around it. Now I'm going to place my pairs, because remember, I figured out there are 4 pairs. So I'm going to place a pair here, a pair here, a pair here, and a pair here. And I'm out. So now when I check, all my hydrogens have their 2 electrons, and my carbon does have its 8 because of the 4 pairs.